All right, welcome to part 2 of our spectroscopy lab video. So let's continue our talk about Beer's law. So we talked about the fact that there is a linear relationship, and here is our equation. And A again is our absorbance, and C is our concentration, usually in moles per liter. And epsilon and L are constants. And so what we'll often do is that we'll make a graph of our data. So we're going to look at multiple concentrations of our sample, use our spectrophotometer to measure the absorbance, and by graphing this data we can actually find epsilon pretty easily. It's going to match the slope of our line. And so on this particular graph right here, we have concentration in moles per liter. And so one thing I want to emphasize is the parameter that we control is going to go on the horizontal axis. And so in this case, it's going to be molarity. So as you're making your graphs, always think about which parameter do we have control over. In this case, it's concentration. That's going to be on our horizontal axis. But then for our vertical axis right here, what we see is that this is going to be the thing that we measure. So we don't control the absorbance. We're going to measure the absorbance with our instrument, and that's going to go on our vertical axis. And so another key item right here is notice that there is a 0, 0 point included. So at 0 concentration, we're going to have 0 absorbance. This is the value you're going to have essentially when you set your instrument, the 0 point, 100% transmittance, 0 absorbance, a little hard to explain, we don't need to get into it. But essentially, you're going to have an accurate 0, 0 point. So do include that in your graph right here. And so then we're going to use Excel once we graph this to figure out the slope of our line. It's going to spit us out a linear equation, and the slope of that line is actually going to equal our epsilon value. So we're going to figure out our constant for the yellow dye that we'll be testing in the experiment. So let's talk about the Spec 20. And so this is our spectrophotometer. As you can see, it's pretty old school, but heck, they're good workhorses and they still work. So right here we have our display for the unit. So you're going to see numbers read out on this display. It's a digital display. Old school ones actually had a needle. Those were crazy, but we have the slightly less old school model right here, which has a digital display. And so we also have a mode button. This is going to be used to switch between absorbance and transmittant modes. If you looked at the procedure already, then you might have seen that we're going to be switching back and forth pretty frequently between those absorbance and transmittance modes. And so we're actually not going to be using these other buttons right here. So just forget about those other buttons. We don't need them. And additionally, we have the wavelength knob. So this knob right here is used to adjust the wavelength. And so we'll be looking at a bunch of different wavelengths actually in this experiment, so you'll be using this knob quite a bit. Over here to the left we have our sample compartment. So there's a little lid that flips up right there, and you're able to put the cuvette inside. And the cuvette's just essentially a really finely made test tube that holds our sample, and it's designed to be like really precise and work well with the instrument. So it's a high-end test tube of sorts essentially. And down here to the lower left we have a filter. And so unfortunately what we see is the detector sensitivity and the light source, they kind of vary with wavelength. And so as we adjust our wavelength, we're going to have to flip this filter at one point or another in order to make sure that our instrument's working correctly. So again, as you change wavelength, you may need to flip this knob, and the transition point's right around 600 nanometers. So if you cross a 600 nanometer threshold during an experiment, you're going to have to flip the filter right here. And if you forget to do that, it can cause problems, so pay close attention. And then right here we have a knob that serves two purposes. It's both the on-off as well as the zero transmittance. So we're going to use this to set the 0 point on the instrument, and so this is part of calibrating the instrument, and it talks about why we're doing that in the handout for this lab if you look at the procedure. And over here we have the 100% transmittance knob. We're going to use this to essentially zero out the blank, and the blank's going to be a cuvette containing some water. So we're subtracting out the light absorbed by the glass of the cuvette as well as the water. And again, if you want to know more about why we're doing this and some details of the experiment, please look at the procedure. All right, so let's talk a bit about the lab notebook preparation. It's similar to some of the labs we've done in the past. I want you to write a brief purpose section. This purpose section is going to just briefly describe what the goals of the experiment are. So what's the problem we're trying to solve here, as well as what our learning objectives or learning goals are here. And so if you give the procedure document a good look over, you should be able to identify these pretty clearly. All right, so another thing you're going to need in your lab notebook after the purpose, you're going to want to include a procedure. And so the procedure you want to make sure is quite clear and quite detailed. And you might even want to kind of sketch some things you see in the pictures in the procedure for this particular lab. And the reason for that is there's going to be a lab quiz later in the quarter. In that lab quiz, the only thing you're going to be allowed to help you in this as a resource is going to be your lab notebook. And so you want to make sure you have really good procedures in there and whatnot, because that's going to help you on that lab quiz later in the quarter. So again, make sure you have all the steps for the procedure like clearly in there so you can do them again if you need to. And make sure you might even want to consider making little sketches of the steps that include some photographs in this particular procedure to help you use the instrument. And then finally, you're going to have, before you get into lab, you're going to have to set up your data section. And so you want to make sure that you leave a space to record the observations about each solution. And you want to make sure that you have two data tables. And so two data tables, each one containing 2 columns and 11 rows. And this is where you're going to have your lambda max data. So one of these is going to be for the blue solution, one of them for the red solution. And you're also going to want a data table containing 2 columns and 6 rows. And we're going to use this one for the Beer's law plot. And so here we have sort of an illustration of what those tables should look like. Lambda max for red solution, make sure you put in a descriptive title. So notice we have a title here that clearly tells the reader what they're looking at. This is the red solution, and it's the lambda max portion of the lab. And we've included also wavelength, and notice I have units there, and absorbance. So absorbance actually has no units, but our wavelength is going to be in nanometers, so make sure that you include units with that. And we have a descriptive title over here, lambda max data for the blue solution. So we have a clear title, and again we have our columns labeled, and we have units when appropriate, so units for the wavelength. Absorbance has no units. And then our last table is shown right here. So again, I have a descriptive title. Beer's law data for yellow solution. So it tells us what solution we're looking at. It tells us what part of the experiment, but here is a very important part. It tells us what wavelength. So it's very important. Make sure that you report the wavelength you measure these at. And table title is a great place to do that. So again, make sure the reader knows what they're looking at. And so in this case, we have molarity and absorbance. And I haven't listed units because molarity actually is a type of unit, so we don't need to say molarity in molarity because molarity is already a unit of concentration. But again, the absorbance doesn't have units, so no units for that one. All right, so that's the end of part 2 of this video, and then we have a third and final part coming up where I'm going to help you with the Excel aspects of this particular experiment. So I will see you briefly, I'll see you shortly in part 3.